Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a concept of methods of preventing the separation of boundary layer. So in our last lecture, we have discussed regarding the separation of boundary layer, how the boundary layer is separated from the solid surface. Now in this lecture, we'll discuss how to stop the separation of boundary layer. That means how to prevent the separation of boundary layer. So what we have discussed in the last lecture, just I'll have a recall on that. So this was the same object or same solid surface what we have considered in our last lecture. So for your better understanding, I have taken the same picture again. So this is the solid object or solid body what was considered for the separation of boundary layer. Okay. So mostly when we will discuss about the separation of boundary layer, we will consider a curved surface. We will consider a curved surface on behalf of a flat one or a smooth one. Okay. So this curved surface is nothing but this one. I can say this is our solid body. Okay. And the fluid is flowing over the solid body with a velocity of u, with a uniform velocity, or you can say free stream velocity. This is called actually free stream velocity. And when the fluid is flowing over the solid surface, we know that there will be a boundary layer formation. A smooth layer will be formed near to the surface of the solid body, and that smooth layer is nothing but boundary layer. And also inside this boundary layer, we know that different velocity of fluid will be there, and that if you plot, will get a velocity gradient, or you can say distribution of velocity with respect to the y direction. We can get it. So in the previous lecture, what we have seen that different conditions we have identified there. Okay, we have identified different conditions. So what are the conditions are there? First one, we have seen that one condition is there when dp by dx when is less than equal to 0. At that condition, we got our du by dy is greater than 0. Velocity gradient is greater than 0. That means the velocity gradient was positive and the pressure gradient is negative here. So for this condition, the boundary layer formations will be there. Boundary layer formations will be there over the solid surface. Boundary layer formations will be continued along the flows in the solid surface, you can say. But again, we have seen that when du by dy is less than 0 and our dp by dx is greater than 0, that means this is negative and this is positive, then what we have seen, the boundary layer formations, boundary layer separated from the solid surface or solid body, separated from solid body. This one already we have discussed in our previous lecture. And one more point we have seen that where du by dy equal to 0 and dp by dx is also equal to 0, then in that point, the point of separation started. That means the boundary layer separation started from this point. So that is called boundary layer point of separation point. So that point is nothing but S point in this picture. You can see at this point the boundary layer started separating from the solid body. So these are things we have seen in the previous lectures. So why this prevention is required actually? Why these first things? Why this prevention of separation of boundary layer is required? Okay, why you need to stop this separation of boundary layer? For that, actually, one reason is there, I'll tell. We know that the boundary layer started separating from the solid surface, that I told you S. Okay, that started separating, but at certain point will arrive in this flow. Now you can see this is the D point. The certain point what I'm talking, that is called D point. So that in the D point, if you see, okay, there is another boundary layer, another velocity profile created, but here if you see the surface, this is the surface is there. Okay, and here some eddies formations are there. Okay, at the D point, if you see, some kind of eddies formations will be arised here due to this disturbances in flow, and due to this you can say that separation of boundary layer. And these eddies formations, make the flow obstacles. We can say that due to this eddies formation, there will be a loss of kinetic energy because it is obstructing the fluid flow. The fluid which is flowing in the one direction, okay, so due to this eddies, this flow will be obstacle that will be make it in a reverse direction. So that you can see inside this boundary, new boundary layer formation, what is happened here at this point. So the flows are in the reverse direction, okay, and these eddies are making this. Why this reverse direction happened? Because of this eddies which is formed here. So that will make this flow slow and it will go in the reverse direction. Due to that, what will happen? Due to this, our kinetic energy started losing. So due to this kinetic energy losses, so there will be a problem in the fluid. That means what the fluid is flowing. So obviously, why if the loss is arising, why the fluid should be continued. So to avoid this losses, this kind of losses, need this prevention required. This prevention of separation of boundary layer is required. Prevention of separation of boundary layer is required, we can say. Okay, for that I'll tell you some points, some basic things are there, we can discuss on that. Even this is one point. Again, we have also seen in the previous lecture, if you remember, also I told you this momentum loss due to this velocity, this velocity effect, we have some momentum loss and momentum gain. So momentum loss, so this will be actually, this is due to the increase of pressure gradient. So this point is actually, this momentum loss will be where, when there is a pressure is more. So pressure gradient is more, we'll get the momentum loss. And when this pressure is less, we can say pressure decreases, we can get here momentum gain. So we need to always keep in mind, we need to always try to keep the momentum gain so that the boundary layer formations will be continued along the flow. And if the momentum losses started, the momentum loss is nothing but our energy losses, because we know that momentum equal to mass into velocity. Okay, so we need to always try to keep the momentum gain, so that, or we can say that velocity gradient should be negative and this should be pressure gradient should be negative and velocity gradient should be positive, so that we can continue the boundary layer formations, and that's why we won't get any kind of losses in the flow. So to prevent these things, I'll tell you few methods are there. Suppose one method I'll tell you. First one is the flow should be streamline condition. The flow should flows in a streamline. Okay, so we have seen many examples are there when the objects are flying or objects are moving, the fluid will be passed through this object is a streamline condition. So how it is? Suppose let me take a small airfoil type. So if you can see, this is the airfoil, so airfoil type is there. Now when the fluid will be flows over this one, so how this fluid will be continuous its flows, like suppose you can move like this. Okay, so if you see here, there will be obviously a small disturbance will be there in this flow, but the fluid will be flows along the streamlines. You can see the fluid will be not that much disturbance will be there. So due to this flow, a streamline flow, so streamline flow means these flows are, they are moving along with their own path, they are not disturbing to other paths. Okay, and here at the end of this point you can see some wakes formations are there. Okay, some wake formations are there. So these wakes, actually this is the wake, this wake formation actually makes more eddies, and that is the disturbance in the fluid flow. That's why more losses, and we can say we can get some kind of eddies formation, and the losses formations will be there in this energy. But if wakes are very less, then there will be no problem with that. So when the wakes will be very less, when the fluid will be flows in a streamline condition. So here you can see very small wake formations are there, and due to this, okay, there will be no problem in the fluid. See, we need to keep our velocity with a smooth condition. That means the velocity profile should be, the velocity gradient should be always positive. That should be more than 0. So when we'll get more than 0? When along with the y directions we'll get more velocity, like the difference between this dy, okay, du by dy. So that we can see, because mostly we should not lose our velocity, kinetic energy. The loss of kinetic energy is nothing but the loss of velocity. So always we need to keep in mind that we need to boost up our velocity, the kinetic energy. Now this is one condition what I have told you. So the boundary layer will be maintained when, see, we need to keep, as I told you, boundary layer need to be maintained, keep maintained. So when the boundary layer will be maintained properly, when our du by dy will be greater than 0. Now one more example I will show you here. It's very, very simple actually. It's given many textbooks also same method. So suppose I will take a circular object here, circular body here. Okay, a small circular body what I have taken here. Now if you see, when the fluid will be flows over this one, now we can see there is a flow will be like this. Okay, and I'll take another one will be there. So it will flows like this. Okay, see, though the fluid is flowing, we are showing in the streamline condition. Okay, though the fluid is flowing in the streamline condition, but you can see, okay, a huge gap after this body. Okay, a huge gap is there after this body. So this gap is nothing but here we'll have a formation of wakes. So here we'll get more number of wake formations, or we can say a large wake formations formed at this point. Okay, so due to these, okay, there will be a problem in the fluid flow. So this wakes or the eddies which is formed here, we can say, so okay, these will be create a problem in the fluid flow. The fluid will be not in the streamline condition. Okay, so we should avoid this one. If this is the condition, then we are going to lose the velocity. That means we are going to lose the kinetic energy. So we need to avoid this. So the flow should be streamline condition, or you can say the body should be actually, if you consider the body as a smooth one or streamlining body, okay, that one you can say also this is like this one as a streamlining body. The body should be in streamlining position, it should be there, streamlining body. This is one condition. Okay, second condition I will show you. Second condition is there, we need to, if some kind of losses are there in the kinetic energy, we need to boost the kinetic energy. So that can be done by supplying, I can say, by supplying additional energy. By supplying additional energy. Additional energy is nothing but additional velocity we need to provide to the fluid. Okay, it may be additional energy can be supplied by some kind of fans or blowers. It can be considered. We can consider some kind of fans, or we can consider some blowers. Actually, the blowers will be provide some extra energy due to the extra additional or external flows. So this can be like, you know, how it will be. Suppose where the velocity drops. Okay, suppose a body is there. Now we can see, yeah. So this, yeah, in this body, let have a slot position is there. Okay, there is a slot position is there, and after that it is like smooth is there. Now due to this slot position, we can say this is called actually suction slot. Okay, if the body's position is like this, and the fluid will be flows over this. Now at this position, if you see, these are the smooth condition, flow will be there. At this point, the flow will be smooth. But when this fluid will be flows over this one, so at this point the velocity is started dropping here. The velocity is trying like it's weaker here. At this point, the velocity weak. Okay, so if velocity is weak, then we have a problem in that. Okay, our velocity should not be weak. It should be always keeping strong, or it should be in the flowing conditions. Okay, so that we won't get any kind of losses in that. Now if this is the body is there, and in the suction slot, if you see, we have a velocity weaker is there. Now to this slot position, we can keep some kind of blowers, or we can use some additional fans or blowers to boost up the velocity from here, or boost up the energy from this point, so that we won't get any kind of disturbances in the fluid flow. The velocity difference should be maintained properly, so that we can see, we can maintain the energy, and due to that we can avoid the boundary layer separation. We can avoid the boundary layer separation by this. Okay, So we need to find out that fluid should be that when the fluid is going inside, okay, we can see it there. When the fluid is going inside, we can see the du by dy, that will be equal to 0. Okay, that means it's already ended at this point. So new boundary layer formation should be started from that. So at that point, we should the separation will be supposed to start when the fluid is going inside in the section slot. So we can do one thing, we can put a blower in that, so that the velocity will be increased, as I told you, so that there will be no separation of boundary layer formed there. Okay, this is another point. The next one I'll tell you. So the next one, when you consider the body, we need to consider very carefully. Okay, so some kind of roughness can be created in the body, so that is called actually creation of roughness. So that is artificial, we can say artificial roughness, that is called artificial roughness. So the artificial roughness will be created in a body if it is very smooth. Now suppose a ball is there where we have a smooth, like previously as I shown you previously, smooth ball is there suppose. So when the fluid will be flows, so it won't obstruct anything, and just it will be move and it will be created, weak will be formed here. Okay, so weak will be formed at this point. And to avoid this, so this one already we have seen here previously. Okay, so if you put some kind of roughness in the surface, okay, some kind of roughness in the surface, then we'll get the velocity will be not have that much problem, and we will find a small weak in this. Now this is what we got previously, large wakes are formed actually now. So when you create some kind of roughness in this smooth body, in this ball, okay, so the ball will be like, you know, it will be circular type, but inside this we'll have a it is not exact, I'm not being able to do, so some kind of holes will be there, or you can say some roughness will be created. It is not that much smooth should be there. Okay, so the velocity profile, or you can say the fluid which when it is flowing through this rough ball, okay, so there we at the outlet we can see very less weak or small wakes are formed here, not weeks, that is wakes. This is small wakes will be formed at this point. Okay, so because we are trying to keep the velocity maintained properly here. Okay, and in this point we'll have a large number of wakes formations will be there. Because of this, we have seen this is normal ball. If you see some kind of even in cork ball or deuce ball, when it is very smooth will be there at the surface, but when you consider this is suppose our cricket ball, you can consider, but in the cricket ball also we have a, you know, stitching is there in the cover of this part. Okay, which will be hold properly, and that will be make more benefit to the bowlers, and when it will be in swing or on swing will be there, so there will be impact in that. But when you consider to this kind of ball, that is, or you can say this is previously you have seen some rubber balls used to there flat, there is nothing in the surface, purely smooth it is. Now this one, or I can say this is a rubber ball also, there are no strip, nothing was there. And this one you can consider some kind of golf ball what was played. Okay, so in that we have seen the roughness in the surfaces. Okay, so that it will be act properly, or we some small wakes should be formed, so to avoid the boundary layer separations. This is one of the point. Now a few other points also there, like I'll tell you now. Another one is we need to provide a bypass slot. We can give another point is providing a bypass in the slot, in the slotted wing, we can say provided bypass in the slotted wing. So what is the meaning of this? See, always our target should be your velocity should be maintained properly. Your velocity should be maintained properly, and there should not be no loss of energy. So in the provide bypass slot, in the sense, suppose this is the smooth body there, and I'll create a bypass in this bypass of the wings. Suppose this is the small blade is there, or any kind of wing is there. So in that, now see, normal previously it was flat, or was there is connection is there. Now I have made a slot in this. So when the fluid will be flows over this one, we can see this fluid will be also, like, it may flows in this direction or it may be flows in this direction. Then the fluid will be continued in this proper way. And why this slot was given? Because here we are trying to reduce the area, okay, so that the velocity will be continuous its directions, and its movement will be faster. And due to that, see, when the fluid will become and it flows through the slots, then obviously the velocity will go very fast when it's coming out from this. Okay, similarly, if it may come in this direction, it may come in this direction, there is no problem in that. So by providing the bypass slot in the wing, okay, we can get the more velocity in the fluid, okay, and there will be no we can say wakes are formed here in this also. So the velocity will be increased in that. The velocity will be increased in this point. Now another one point is there. Yeah, providing another one, we can providing a guide vanes. Providing a guide vanes in the bend, in the bend pipe, we can say. When the pipe is in bending condition, let's provide a guide vanes in there, because we know that, suppose this is the pipe, is the bending pipe is there. Let's consider this is the bending pipe. So we know that when the fluid is flowing over this one, so up to this it is very, very good. But when it is coming to this bend, near to the bend, we have a disturbance in the fluid. Like the fluid will be flows like this, and there will be a we can see eddies formations will be there near to this one. Okay, and that will be create some turbulence in the pipe flow. So if you provide a guide vanes there, okay, if you provide the guide vanes at this bend of this pipe, there the fluid will be moves very smoothly. So your velocity will be maintained properly, and that du by dy, okay, we can maintain positively. Okay, this is one point. And similarly, some other points also there. Many points are actually there. We can see, like, by using some vertex generators, okay, and we rotating the boundary in the direction of flow and small divergence in the like flow directions, that differences will be there. So many points are there in this related, but these are the some small points you can remember easily. That's why I have discussed this one. So I hope you understand this theory of preventing the separation of boundary layer. That is most important. We need to keep in mind that velocity need to be maintained properly, and the difference velocity gradient need to be always keep in positive way. Then we can prevent the separation of boundary layer. So I hope you understand this theory. If you're having doubt in this, you can give a comment in the comment box. Thank you.